Okay. So I think the last what we discussed so far, I think is already covered in last session. So we have not missed out much. And yeah, so let's just discuss this, right? So basically it's this topology is basically symmetric asymmetric combination, right? So basically it's not asymmetric, it's combination of symmetric and asymmetric IRB. So there are two VTAP pair, VTAPs, individual VTAP, VTAP1 and VTAP2. If you see here, it has three SVIs. VTAP A has three SVIs, VLAN 10, 11 and 20. And VTAP 2 has again three SVIs, 10, 20 and 12, right? So if you see here, VLAN 10 and 20 are common on both the VTAP, so which is nothing but asymmetric IRB. But VLAN 11 is only on the VTAP 1 and VLAN 12 is only on VTAP 2, right? So basically this is symmetric IRB, right? So it's a combination of symmetric and asymmetric IRB, right? Now let's see what will, happen, right? When VTAP 1, basically, let's say this host H1, right, sends our packet, or basically RP is learned locally on this WRF, right? On this WRF. What it will do is it will generate type 2 route, MAC IP route, right? When it received here for VLAN 11, right? You don't have SVI 11 here, right? It's not there. So what it will do is it will create type 2 basically route, IP route for customer A WRF into customer A WRF, because this guy also will send VNI, L3 VNI, right? So based on that, it will identify that this VLAN, this VNI is belongs to this WRF. So it will install the route that for to reach out 11.11.11.10/32, you send packet to VTAP 1, right? 200.1. So this is the VTAP. VNI 1000. So this is the IP WRF VNI, IP WRF VNI, right? And MAC is this MAC, this router VTAP 1 MAC, correct? So basically it is updating type 2 route. Okay. What? So that is one thing. Okay. Because this SVI is not present. Now let's talk, think about, you have VLAN 10 host here, right? VLAN 10 host, VLAN 10. This ARP is learned locally here for this host, right? 10.10, let's say 10.10. Again, it will be sent type 2 route, right? With L2 and L3 VNI, correct? When this route received here, right, it will check that VLAN 10, basically L2 VNI, right? That is also present here. SVI is present here, right? So what it will do for this 10.10, it will install this information into ARP table, right? It will update the ARP table based on L2 VNI information. It will not consider L3 VNI information for this. Okay. So that's the difference depending on which VLAN you are receiving, whether it's locally available or not. If SVI is unable, then it available, then it will populate ARP. If it is not there, then it will install into IP route. Okay. Is it clear? Any question on this? Okay. So now let's talk about, so we will also generate type 5 route. Okay. So I want to discuss, let's discuss on type 5 route. Okay. So let me first, open type 5. Packet capture. So if you can see here in a single update message, right, we are sending a lot of information, right? Different types of routes, right? So if you see this first one, so that is IP type 5 route, right? So this first one is type 5. Then if you check the next update message, it is also type 5 route. this is type 3 route, right? IMATE route. So basically in single message, we are sending multiple different type of information in one update message. Okay. So now let's discuss about type 5 route, right? So basically, if you have noticed here the configuration, right? Show run BGP. So we have this IP WRF configured, right? And show run interface VXLAN 1 and WRF to VNI mapping is also configured, right? Now we have RD, separate RD and RT value for that IP WRF, and we have configured redistribute connected, right? The way same in MacWorf we have configured redistribute learn. What does that mean? As soon as in for this VLANs, right, we learn MAC or ARP information, we will redistribute, advertise by type 2 route. Similarly, what does this mean? Redistribute connected is we show IP route, right? WRF all. Show IP route, WRF all. So basically, this configuration is for WRF A, right? In short, if we say it is WRF A, so this configuration is WRF A. So basically what we are saying is any directly connected route in this WRF that will be advertised, right? So in type, in this WRF, if we check type WRF A, there are these are the two directly connected route for SVI 110 and 111, right? So these are the subnet /24 routes, directly connected route, right? For this WRF. And what we will do, we will advertise this as a type 5 route, right? So basically what we'll do, because of redistribute connected, we will advertise this route as type 5 route, right? So if we check EVPN route type, right? IP prefix, IPv4 detail. Okay. So basically we are advertising this route, right? So what was the one? 10.1.10/24, right? SVI 110 subnet, right? So what we are doing is we are advertising this IP prefix route. This is type 5 route, right? And what are the information we are sending? So this is first locally generated, right? Extended community route target 1010. So this is route target of IP, basically IP WRF route target. Encapsulation is VXLAN, router MAC, right? This is the MLAC system ID of this between leaf 1A and 1A and 1B. And this is the VNI of IP WRF, right? So here we have only IP WRF VNI because it's a type 5 route. So if you check this, this is the, type ID. Hey guys, are you able to hear me?
Yeah, we lost you for a bit, but you're back now.
Yeah, actually my laptop CPU is high. I have disconnected the monitor, so now it should come back. Yeah. Okay. So are you able to see my screen?
Yes.
Okay, perfect. So yeah, this is the type 5 route packet format, right? RDART, Ethernet tag, IP address information, VNI label, gateway, and then route target, extended community, MAC, and tunnel encapsulation, right? So this is the, type 5 route format. And let's see that here, right? So basically MP reachability NLRI, address family AFI, next hop is 254.5, right? And this is type 5 route, IP prefix type 5, route distinguisher, Ethernet segment, Ethernet tag is 0. This is the subnet and subnet mask, right? Prefix and prefix length, gateway, BNI 10, right? So this is the IP WRF BNI. And then we also have, so this is one in update. If you see here, there is another update also IP prefix. So this is for 10.1.12.0. Then we also have update for another directly connected subnet, and then 13.0 as well, right? So we have multiple updates, and in between there is MAC type 2 update is as well, right? In this, why we have combined all this? Because for each of this update, the next stop is this VTAP, right? This VTAP has originated all these update messages, that is type 5 and type 2. That's why we have combined all these update messages into one, basically into one this, update, right? And multiple update messages are part of this when we send out this BGP information. Okay. So, and then, yeah, we have extended communities, which is route target, IP verf, route origin, encapsulation. We extend encapsulation and router map, right? So basically, these are the all information which we will advertise here, right? And which is also present here. So based on this, information, right, we will install this /24 route, right? So this is based on type 5 route information. So we will install 10.1.12.0/24, right? Which VTAP? It is the VTAP 2, VNI 10. Router MAC is this, that is the router MAC of that VTAP, and VXLAN 1 interface, right? So basically for the same subnet, right, 12.0 subnet, you have two routes installed into your WAF, right? One is based on type 2 information /32 specific route for that host 3. And this is the subnet route, right? Based on type 5 route update. All other information, if you see, is same, right? Because that is originated by this VTAP. Okay. Is there any question or any doubt on this? Okay. So if we have to get back to this, right? If you see here, we also have type 5 route installed for this subnet, right? 12.12.0/24, which is not common. So on VTAP 1, we install this subnet /24 type 5 route. And similarly on VTAP 2, we will install type 5 route for 11.11 subnet. Sorry, this, where is that? Yeah, it should be 24, right? 24 and 0. So we have installed this route into VTAP 2. We'll not install this route into for this, right? Because common SVIs, because that is already present as a directly connected routes, right? So that is not needed. But obviously for other VSVIs, which is not current present locally, we will also install type 5 route. Okay. Is there any question? Is it clear why we need, basically why type 2 and type 5 both, basically both routes will be advertised in this? Okay. And that's what is this slide talking about, that we'll advertise both type 2 and type 5 routes. Any question so far? Any point if you have not understood, or and you want me to discuss again?
Hey, Vishal.
Yeah.
So I'm just trying to reflect on how, if there, or you go back to your topology there, they're both symmetric, asymmetric.
Yes.
So if the H2 is pinging host 1, sorry, I'm just trying to see how that packet will go from H2 to H1. And
so so go ahead.
And how the remote VTAP is going to use that information to correctly send the traffic to H1. So we'll do a show IP route. We'll see it's 11.11. We'll use that /32, right? And then we'll see it needs to go to VTEP.
Yes.
To that VTEP.
Yes.
So
200.1.
So in the packet, we'll also add that VNI. We add that
yes.
VNI?
Yes. So we'll discuss that, right?
Okay.
Upcoming slides, that how this packet format will work, or basically this will work.
Okay. No
and
worries,
how this all information will be used. So basically we are going to use all these three information. Okay. So basically,
yeah, I was just trying to fill up that,
we
if
have
it's
that
coming.
slide.
Okay, no worries.
So basically what will happen, right? When so as soon as H1 communicates or resolves R for the gateway, right? You learn local MAC and ARP. Same for H2, right? Or let's say H1 initiates ping for H2. So it learns local MAC and R for H1 and also H2 on VTEP2. They will advertise type 2 routes, right, for MAC and ARP. And based on that, and also type 5 routes, as soon as you configure SVI, as soon as you configured SVI of for VLAN 11 here, right, it will generate directly connected route for this SVI/24, and it will also generate type 5 route, right? And as soon as ARP and MAC learn, it also initiate type 2 route. So based on this type 2 and type 5 route, you are populating this table, right? Route table for that WAF. Okay. And now we will use this information, right, to create the table and data traffic, right, to forward the data traffic. So this population of this routing table is control plane, right? Now we will use all this information what we received through type 2 or type 5 update for data transmit. Okay, and that we will see in this slides. Yeah.
Okay, thanks.
Okay. So let's see, how we are using that information, right? So first let's start with configuration, right? Basic config. So basically, as you see here, this is one VTAP, right? And you have, let's say you have two SVIs, right? SVI 10 and 11. Then you will configure both this SVI into this particular WAF, right? So this is WAF A, let's say A, right? So you will first configure that WAF tenant A, right, into on your VTAP, right? You enable IP routing for that WAF, and both your SVIs, VLAN 10 and 11, will be part of that WAF, right? So that will be part of that WAF. So this is the basic configuration, that first of all, you have to create one WAF which is present on all the VTAP. You have to activate that, activate routing for that, and all your VLANs underneath, right, should be part of that WAF, right? So that is the primary, configuration. Then next configuration is you other than VXLAN other configuration, that is VLAN to VNI mapping. You also have to add for that WRF tenant A VNI, right? So this is the VNI for that WRF, new WRF you created, which is common on all the VTAPs, right? So this VNI and WRF is common on both the VTAPs or all the VTAPs. And then you have to configure IP WRF under BGP, right? So this is the IP WRF, right? Separate different RD and RT values, route target and route distinguisher. And you will also configure redistribute connected, so that any connected route SVIs, right, you will advertise it as a type 5 route. Okay. So this is the basic configuration on top of what we used to do in asymmetric IRB, right? So this is the extra configuration for symmetric IRB. Okay. Is it clear? Any question on this? Okay. So now let's discuss packet walk, right? So let's discuss that, you have server 12, which is nothing but 1112, wants to communicate to, so this is part of VLAN 100, right? So this is VLAN 100, and this is another VTAP, this is VLAN 200, server 23, and 2223 is the IP address. Okay. So basically we want to communicate between VLAN 100 to VLAN 200. It's a symmetric IRB. So you don't have SVI 200 here and SVI 100 here, right? We will be communicating through common WRF, right? Which is nothing but this WRF. Name is 100, right? And VNI configured is 111, right? So now, as we discuss, right, what this guy will do as soon as this ARP or MAC learn locally, it will advertise type 2 route, right? And based on type 2 route, because that SVI is not present here, we will into this WRF, IP WRF, we will install this route, right? What are the route? What is the route to reach 222.3/32? This guy, your next hop VTAP is 2221, right? You have to send packet to this VTAP 2221, okay? With VNI information 111, that is this IP WRF VNI, and router MAC of this guy's MAC, VTAP 2's MAC, right? So this is what we have sent all the information in type 2 update, and based on that, you have installed this route. Is it clear up to this? Any question? Okay. So now, once we basically we will now craft the packet, right? We have to send that out over VXLAN, right? So what we'll do is, this is our ICMP packet, right? This is our original ICMP packet, and top of it, we are adding VXLAN header as it has to go out towards from VXLAN. So what is the source IP? We are pinging from 10.111.2, right? And pinging to 2223. So this is our destination IP, right? So source IP, destination IP. What will be the source MAC? So as we are routing, right? Basically, see, when we send out this packet, source MAC will be this MAC, destination MAC is gateway MAC, right? Right. Now we are routing this packet from VLAN 100 to this SV, basically this VNI, right? So now when we send this out, our source MAC will be this VTAP MAC, right? This VTAP MAC, which is nothing but your AMLAC system ID of this VTAP. Okay, so this is the source MAC VTAP 1, right? Source MAC VTAP 1. Destination MAC is VTAP 2. This is the MAC which we received through type 2 update and is what we have, installed here, right? So if you remember here, this VTAP 2 MAC we already have received, right? And we have installed here. So this is what we will take it from this route, right? To fill that header information. So this inner destination MAC is this MAC we are getting from here. Top of this, we have to add VNI, right? VXLAN header. So in that one is VNI. So this is VNI is what we received, right? So we will use this VNI from this route table, right? 111. So that is IP WRF VNI. Destination VTAP IP is VTAP IP of the VTAP 2, source VTAP 1. So basically this is outer, outer header, right? So source IP is your VTAP 1 IP and destination VTAP IP is your VTAP 2 IP, right? This 2221, which we have received. So basically we are getting all these three information, right? Via type 2 route update, and we will basically fill in that information and send this packet out towards over this link, right? Is it clear? Any question on this? How we have, generated the packet, basically fill in all this data fields. Okay. So now we send this packet out. It is received here, right? At this VTAP, we receive this encapsulated packet, right? Now this information will be removed, right? This is VXLAN packet, right? So basically we will remove it, but before that we will check that, hey, destination VTAP is 2, that is, it is destination IP is my IP. That means this packet belongs to me, right? And destination MAC is also for me, right? So basically this is, I have to process this packet, and VNI is 111, right? So basically it tells that whatever packet I have received, that belongs to this IP verb, right? That which is this IP verb, correct? So basically I will land that packet into this IP verb, right? After that, we will check the destination IP, right? And based on that, we will basically it will be then routed based on destination IP. It is directly connected, so it will be routed into VLAN 200, and from there it will check the ARP table to populate the field to send the packet out, right? Source MAC and destination MAC, right? So this is the packet, right? So basically now you have to send this packet out over this right? So basically source IP and destination IP will remain same, right? But based on your ARP table, right? Local ARP table for 2223, you will put basically fill destination MAC as this MAC. Source MAC is your this MAC, right? This SVI MAC. And then you forward this packet out towards the host. Okay, so this is how step by step packet will use all this information, type 2 or type 5 if required, and forward this packet out. Is it clear? Any question on this? Victor, is it clear?
Yeah, it's clear. So it's a VNI that I was a bit confused. So we're going to use the VNI to check the routing table for that VRF, right? For that
Yes.
IP VAF, right?
Yes. So based on this
Okay.
VNI 111, when it lands here, it will we understand that hey, this packet we have to process and to under this WAF, right?
Yeah.
After that, we will check because this SVI interface is also is part of this WAF, right? So
Yeah.
basically, this SVI is also part of that same WAF, and you will then when you check when your packet lands into this WAF, you check that hey, what is the destination IP? That is 2223. Then you check the route for this. You see that hey, for 2223 subnet, this subnet you have directly connected /24 route, right? So basically it is your local subnet. Then further for 2223 you will check the ARP information, right? For that subnet under that IP WAF. And then you will find that hey, there is a MAC associated with this, and then you forward the packet out. Okay.
Yeah. So if we have a spine device in between, only the top two will be changing across the path. S
Yes.
mark, D mark.
So
Yeah.
yes. So if you have spine here, right? All this information till here down is this all is going to remain same. Only you are going to change is source MAC and destination MAC, right? So when
Yeah.
this packet goes out, source MAC is this, destination MAC is this outer. When it goes out from here, your source MAC will be this guy and destination is this outer. I'm talking about this field, outer
Yeah.
source MAC and destination. Otherwise, it will remain all same. Okay.
Okay.
Okay. So if we check in lab, right, on leaf 3 or 2A basically, right? Show IP WAF, show IP ARP WAF all, right? So basically this is your 12.103, right? Host 3. This host 3 ARP is learned under that WAF, right? Because that SVI, show run interface VLAN 112, is part of this WAF, right? So your ARP is learned here, and based on that, you will basically forward the packet to this MAC, right? Is it clear?
Yeah.
Okay, so yeah, let's move forward. Do we have? Okay, yeah. So yes, and yeah, then finally this packet, which is we basically change, and that will be forwarded here out. on the interface. So this is overall, overall basically packet, right? So it covers everything, right? So basically this server has started. It's again recap, right, of what we discussed before. So basically when you ping from server 12 to 22, right, what it will do is it will have source IP as your IP, this IP, destination as destination server 22 IP. Source MAC is S12, its own IP. This MAC, sorry, this is the MAC, and destination MAC is gateway MAC, right? This is the gateway MAC. So now this packet comes here, right? Now you check the destination IP 2222. You have route for that 222, which points that you have to send that packet to this IP verb, right? Through this IP verb. So what you will do, your source IP, destination IP remains intact. Your source MAC will become VTAP 1 MAC. Destination MAC becomes VTAP 2 MAC, right? Because your IP route for this guy points out that your next stop is to another VTAP, VTAP 2, and it also gives your MAC address of VTAP 2, right? Here, MAC information. So based on that, you will update source MAC and destination MAC, right? Then you want to send that packet out over VXLAN. So you will add VXLAN header on top of this, on this header, which is nothing but IP verf VNI, because you are sending this packet through IP verf. So VNI is IP verf. Source VTAP IP is VTAP 1. This is this VTAP. VTAP 2 is destination IP. And then your MAC addresses, right? Outer MAC. And that's how your packet is forwarded. So basically this is combination of all the slides, right? And then next slide is, further that you received, basically you received this packet here on VTAP 2, right? What you will do is you will remove this, all the information, right? All the headers, extra headers. You are left with these things, right? So one source IP is same, destination IP is same. Now your source MAC is this VTAP MAC, right? This SVI MAC and destination MAC. So this is what you received first of all, right? You have removed all this extra headers, VXLAN header. Now you are left with this, right? So if I have to clean it properly, basically we remove all these headers, right? VXLAN header here after this decapsulation, and we are left with this part, okay? Now here again we will check what is the destination IP. It is directly connected through SVI 200, right? So it will route the packet into SVI 200. Source MAC is that SVI MAC, and destination MAC will be the based on ARP table, that MAC of that, right? That MAC of the server, and forward that packet out here. So basically, if you are confused, you can refer this diagram to understand which header will be changed, right, at each each stage. Is it clear? And yeah, there is a step-by-step explanation as well. Is it clear? Any question? Okay. Now, so what we discussed so far, right, is one way of symmetric IRB or IP verf, usage of IP verf, right? So what we discussed so far was this one, right? So so basically what we had is, this is one VTAP 1, VTAP 2, right? We have multiple SVIs, SVI 100 here and SVI 200 here. And we have used common verf, shared IP verf, right, to communicate between SVI 100 and 200. So this is the one which we use so far in this particular discussion, right? But there are other ways also available, right, to basically achieve or implement same thing. Basically, your end goal is to communicate between SVI 100, VLAN 100 to 200 hosts, and SVI, it's a symmetric IRB, right? So SVI 200 is not present here, 100 is not present here. So one way what we did is, having common IP WRF through which we can communicate between two SVIs. What if your router or VTAP switch does not support IP WRF, right? IP WRF is not supported. Then you can also use global default WRF or routing table, right? To achieve the same symmetric IRB. Same symmetric IRB, you can still configure with default WRF, global routing table. It's not mandatory to use IP WRF to communicate between two SVIs, okay, in symmetric IRB. So that is also possible. In fact, you can also have different IP WRF. Let's say you have two different customers, right? Customer A and B, right? Customer A has VLAN 100 and customer B has VLAN 200 connected here, right? And they want to communicate with different VLANs 300 and 400, right? On another VTAP. Now, obviously, you don't want to mix routing table of customer A and 2, right? It should be separate routing table, right? WRF. This is WRF A and this is WRF B, right? So what you can do is between these two VTAPs, you can have multiple WRF, right? So this WRF is customer A WRF, which is to communicate between these two VLANs, and the green is for customer B WRF to communicate between these two. So basically multiple IP WRF is also possible, right? With this scenario. And what you have to do is, if needed, you might have to do route leaking between these two WRF if required. Okay. Or even in fact, you can have for each VLAN, you can have separate WRF, right? So that is also possible. So basically, let's say you want to communicate between 100 here, 100 to 200, then you can have one WRF A for 100 and B for 200, and you can, make it work. So these are three different ways we can achieve this symmetric IRB. Okay. Most commonly used is this one, which we already discussed, right? The other two customer might use depending their requirement, but the most common is the one which we have used. Okay. If you want to check the configuration changes or the outputs related to this two other two, there is one design document on VXLAN EVPN web page. So there where you can find, in fact, you can find all the configuration for asymmetric, symmetric, different variants, VLAN based, VLAN aware, everything. Okay. So that you can find out. I can ping that in our group as well. Any question? Okay. Now let's talk about, advantage of symmetric IRB. So basically we already discussed some of them, right? So obviously with symmetric IRB, right? One advantage is because this host, right? This are different SVI. You don't have that SVI here, right? That SVI, basically this is 112. 112 SVI is not present on this VTAP. You don't have to learn ARP, right? So ARP is, you don't have to learn, correct? For this, all the hosts. You also don't have to learn the MAC address for all the hosts, right? So basically MAC and ARP, you don't have to learn. What you need to know is MAC address of this VTAP, and you can just forward the packet to this VTAP, right? So basically you don't need to populate ARP and MAC table for all this host in symmetric IRB. Also, you do not need to have VLAN to VNI mapping for this VLAN, right? Because this VLAN is not present here. So you don't have to configure VLAN to VNI mapping for VLAN 112, right? So basically, yeah, these are all the advantages of symmetric IRB compared to asymmetric IRB, right? So yeah, these are all the advantages of symmetric compared to asymmetric IRB. Okay. But basically symmetric has one problem, or we can say disadvantage, right? Is that you have to have /32 route for all the hosts, right? So basically your route table will be now large, correct? Obviously ARP is not there, but your route table. So basically now you need to have, route for all this host, right? /32 route for all this host on this VTAP, right? /32. So basically, if you have 100,000 hosts, right? 100,000 hosts in your network, this VTAP, all the VTAP should have this 100,000 routes, /32 routes for that host to forward that packet. Okay. Definitely, if it is too separate, it's not overlapping, you can use only type 5 EVPN, right? L3 EVPN. And you can have just /24 route, right? For this whole subnet here. It's not needed that all /32 route is needed on this VTAP, right? So there are different ways to reduce the number of routes. But yeah, if you want to wish to get all /32 route, then that is again that can consume resources. Okay. So yeah, that's the. So basically, yeah, this is just in which platform and from when this is supported. And this is our lab topology. Maybe tomorrow we'll discuss more on basically we'll play with the commands. We'll go through configuration again once more, and then we'll play with command outputs. Okay. So yeah, that's all for today. Any question for any of the whatever we have discussed today? Okay. So in that case, I think, yeah, let's stop here and we'll sync up again next week. Thank you.
Thank you.
Thanks, Vishal.
Thank you, Vijay.